Hello, my name is Long Fu, and today I'll be teaching you how to use trigonometric identities. There are many identities, and there are a variety of ways to use them in simplifying expressions. These are called reciprocal identities, and they're basically the inverse of each other. So as you can see, sine theta equals 1 over cosecant theta, and cosecant theta equals 1 over sine theta. And you can see that it's like that for the rest of the other identities. These are quotient identities, and they're basically just tan theta equals sine theta over cosine theta, and cotangent theta equaling cosine theta and sine theta. These are Pythagorean identities, and um, they could basically be rearranged to, so as you can see, it's sine squared theta plus cosine squared theta equaling 1. But what you can do is you can subtract the cosine squared theta, and it'll be 1 subtract cosine squared theta equaling sine squared theta. So if we were to use this in a problem, these identities, I have a problem right here, and it's cosecant theta over sine theta minus cotangent theta over tangent theta. To subtract fractions, we need to find a common denominator. So let's work from left to right. With cosecant theta, we can simplify it to equal 1 over sine theta. So we could get this to sine theta squared. And this would be a common denominator because we know tan theta equals sine theta over cosine theta. So let's see. Cosecant theta would equal sine 1 over sine theta, and this would just stay sine theta. Subtract. To simplify these two, we can use the quotient identities. So it's cosine theta over sine theta and sine theta over cosine theta. So then this would be um, this would change into, so pretend this, oh wait, no. This would become 1 sine squared theta because it divides, so it would be 1 sine theta, and the fraction here is a division, and we have to flip the sign, so it would be 1 sine theta. That would equal 1 sine squared theta. So there's our answer right there. And for this, it would become cosine theta versus sine theta. And then we would obviously flip that like we did this. Oh, this changed to multiplication too. Multiplied by cosine theta and sine theta. And that will give us our common denominator of sine squared theta. There. 2. And that would obviously be cosine. Sorry. Cosine squared theta. So let's do this. Cosine. Oh, it's a bit close. Sine squared theta. Okay, there we go. Now we can actually subtract this. So let's do 1 subtract cosine squared theta. Oh, I forgot to write the 1. So that would be 1 subtract cosine squared theta over sine squared theta. So this is when we can actually use our Pythagorean identity. So it's 1 subtract cosine squared theta. So if we subtract this, then that'll be equaling to sine squared theta. So sine squared theta. And since we have sine squared theta on the bottom too, that would just equal to 1. So that's our final answer. Oh, oh, so yeah. And let's do another example. I'm gonna have to resell this. Can I make it bigger? Uh, okay, almost there. Okay, so if we were given another example, maybe something simpler, like secant theta subtract sine. Oh, I'm writing it really bad. Sine theta and just tan theta. So, um, so we have secant theta, sine theta, and tan theta here. What we first should do is maybe try and find a common denominator within these two. We know secant theta is 1 over cosine theta, and we know tan is um, sine theta over cosine theta, so maybe that'll work. So 1 cosine theta subtract sine theta and sine theta over cosine theta theta. Okay. We did that because there was a minus here and we needed to find a common denominator. And since we know sine theta doesn't have anything in relation with secant theta, but tan does, and we're multiplying these two, so yeah. Then, as I just said, we're gonna multiply these two because there's an invisible multiplication here, and that would be sine squared theta over cosine theta, and we bring that down too, and that would basically equal 1 subtract sine squared theta over cosine theta. And if we refer to this again, that would equal cosine squared theta. Cosine squared theta over cosine. And that would leave us with just cosine theta. So that's our answer. So those are the examples of how you would use these identities. There are many more ways to use them, including I didn't find any examples. I mean, use any examples with these two, but there are many other ways you can solve them, and yeah. Thank you for listening to my little presentation here, and yeah.